Hi everyone, welcome back. Hope you're doing good. In this video we will learn about merge sort. In the previous video we learned about the merge technique, which is the heart of our merge sort. So you need to watch the previous video before watching this video, because that's a prerequisite for understanding the merge sort. So in the previous video what we understood, basically if there are two sorted arrays, or if there is an array and part of the half of it is sorted and another half of it is sorted, and if we take the entire array, if it is not sorted, then we will sort it by merging the elements from the first half of the array and from the second half of the array. So that's what we learned, and we will use the similar technique in this algorithm to sort the elements that are there in this particular array. So let us try to see, is there any way, where we get part of the sorted array and another part of the sorted array. So if I divide maybe half, do I get it? No, because the numbers, we don't know in which order they are. So what we need to do, we need to get to a level where we get only one element. So if there is one element, then it is considered it is already in its sorted order, and from there we can merge and we can get the sorted array back. So what we can do, so basically this algorithm follows divide, keep on dividing until you get a single element, and then merge those elements backwards. So basically this algorithm tells divide and then merge. And one more thing to mention here is, this is a divide and conquer algorithm. So what exactly is a divide and conquer algorithm? So we divide the bigger problem into smaller problems, and then we solve those smaller problems, and then we combine together to get the solution for the bigger problem. So that we understand here in this particular example. Let us see. So what I was trying to say, we will first try to divide this problem into a small possible problem. That is, since there are 8 elements, we will divide it in such a way we will finally get single element. So what I will do, I will divide this array into two halves. So we are not really dividing it, but hypothetically we will assume we are going to divide this into two arrays. Okay, now whether these elements are sorted? No. So then what I will have to do, I will have to further divide it. So what I will do, I will divide two numbers now. Okay, I divided, but still we cannot assure that the two numbers are in their sorted order. So what I will do, I will further divide this. So what I get, finally I get one element in my array. So if I get one element in the array, it is already in its sorted position. So from there what I can do, I can start merging the numbers. So now what I will get something like this. So if you take these two, they are already in their proper sorted order, because 21 is only one element in this array and 15 is one element in this array. So what I will do, I will keep pointer and I will merge. So out of these two, which one is smaller? 15 I will take. So this technique you can refer the previous video. This is how we do the merging. So we will compare two elements and we will take the smaller one and then we do the increment. So this gets incremented. So once it is outside this particular array, then what I will do, I will keep the remaining element here. So I did for these two elements. Now what I will do, I will do it for the next two elements. So since they are in their proper order, 7, 8, this also in proper order, 3, 5, this also in proper order. So if you see, now after this particular step, in this step we got properly sorted arrays. So here we can surely say these elements are in their sorted order. So now what we can do, we can again apply the merge procedure to merge these two arrays. So now I will put a pointer here, 7 is smaller, I will take and I will increment. 8 is smaller, I will take and I will increment. So now it is out of the array, so I will simply take remaining elements and I will put them here. Now again I will repeat the same step here. 3, 12, 3 is smaller, so I will take 3, I will increment. Then I will take 5, I will increment. It moved out of the array, so 12 and 14, I will copy them. Now I will again repeat the same step. So here I will put the pointers. So out of these two, 3 is smaller, so I will place 3 here. I will increment this pointer. Next is out of 7 and 8, 5 is smaller, so I kept 5 here. I will increment this pointer. Now out of 12 and 7, my 7 is smaller, so what I will do, I will increment this and I will place my 7 here. 7 is already there. So now I will, so this is incremented. 12 and 8, out of 12 and 8, 8 is smaller, so 8 is here. I will increment the pointer. Out of 15 and 12, 12 is smaller, so I will take 12 here and I will increment the pointer. Out of 15 and 14, 14 is smaller, so I will place 14 here and this moves out of the array. So my remaining elements are 15 and 21. So 15 and 21. So if you see at the end, we got properly sorted elements in my original array. So here we are not doing anything extra apart from merging the elements. That's why merge technique becomes a heart of this particular algorithm. So what we did, we divided the bigger array into smaller arrays. So we don't really divide that. I mean, we will see that in the logic and what exactly we do, but we will divide until we get a smaller element. Then from there we go back and start merging the elements. So this is also called post order traversal. Why? Because first we kept on dividing the array. Then once we get the smaller arrays, that time we started tracing back, basically merging back the elements. That's why it is also called post order traversal technique. Okay, so now let us try to understand this a little bit more. I mean, we want to write the program for this, right? I mean, basically this uses a recursive program. So what we try to do, first we divided this much, okay, and then again out of this we divided this much, then we divided this, we solved this. So if you see, this is coming like this, like this, like this, like this, and then finally, so here division happens, division happens, division happens. Then once we get single element, then merge starts happening. So here this is one point where these elements are merged. Then again the next array gets divided. Then once we get this smaller array here, the merge happens. The second merge happens here. Then again division. So here again the division, then division. So here the third merge, here fourth merge, and finally here the fifth merge for these two arrays. And finally we get back our merge sort. So if you see here, what we are trying to do, first divide this half, but solve first half. Then again this one divide into 2, then solve first half. Again this one divide into 2, but we got the minimal problem, so merge back. Again the next half. So here we solve the next half. So what exactly we are doing? First we are dividing the array into 2 equal halves, and then we are merging it. Let's look into its pseudocode now. I will remove this. So now let us take a method merge sort, basically, okay. and we pass array A, and we also pass the low, which is this, and this is the high basically. So comma high. This is the initial thing what we need to pass. Then what I will do, if my low is less than high. So why low is less than high? If low and high becomes same, then that's where we get one element. That's why until the low is less than high, what we do, we keep on doing something. So what is that? First we will see what is the mid value. Mid is low plus high by 2. So basically we will take the floor value here. We will take the floor value. Okay, and then what I will do, I will again call the merge sort. Again call the merge sort. I will pass the same array A. My low will still be my low, because if this is my low, this is my high, somewhere this is my mid. So if I want to again solve this as a bigger problem, so from here to here I will send it as one array, then from here to here I will send it as another array. So this becomes mid plus 1. So A comma low, this is low, low to mid, and again I will call merge sort A and mid plus 1 to high. So from here to here. So this is my second array. Now after this I will do merge. I will pass A, I will pass low, I will pass my mid here, then I will pass my high. Okay, so this is basically our merge sort. And what is this merge method? So this is what I was telling. I mean, we will have to refer the previous video to understand this particular merge method. We have solved this merge technique there, and we get the complete code for merging the elements. Okay, so now with this, let us try to understand first what this method will do. First I will call this merge sort. I will pass 0 as my low and my n value, which is 7 here. Now if low is less than, low is less than my high, so what it will do, it will try to calculate the mid value, which is somewhere 3. Okay, which is somewhere 3. Next what it will call, merge sort from 0 to 3. So this much, 0 to 3. This one it will call, it won't go further, because that's how, I mean, the recursive program works. So next this becomes my low and high. This becomes my low and high. Again it will come here, my low will still be less than my high value, and again I will calculate the mid will be somewhere 1. So my next partition, my next the dividing happens from 0 to 1 and 2 to 3. So it will try to solve 0 to 1, and again the division happens, it will get 3 and 5 separately, then it will start merging from there. So this is how this logic works. Let us try to understand its time complexity. So what we are doing here, basically we are dividing the array. So this is basically t of n by 2. We are simply dividing. We are calculating the mid value and we are dividing. Again the next half, which is t of n by 2. Okay, then in the merge, what we do, we merge the elements. So basically it is of order n. So if we total it, it becomes 2 t n by 2 plus n. This is our time function, but this is when n is greater than 1. This is when n is greater than 1, and it becomes 1 when n becomes 1. So when we have only one element, that time we stop, right? So there is no work done there, and from there we start to merging the elements back. So this is basically our time function, which is P of n equal to 2 Tn by 2 plus n. So if we refer Master's theorem, here A is equal to 2, my B is equal to 2, and value of K is 1. So log A to base B is equal to log 2 to base 2, which is 1, which is like K is equal to this log A to the base B. So for that it becomes n log n. So our time complexity is of order n log n. So let us also try to understand this in a different way. For that I will remove this code. So initially what we did, we passed 0 to 7. So my n value is 8. So I will iterate from 0 to 7, n minus 1. Okay, next what we did, we divided this into 2 equal halves. So 0 to 3 and 4 to 7. Okay, next what we did, we again divided this into 2, 0 to 1 and 2 to 3. After this 0 to 0 and 1 to 1. This is how the division happened, 3 to 3. So again 4 and 7, 4 to 5, 6 to 7, 4 to 4 and 5 to 5. This is 6 to 6 and 7 to 7. Okay, so this is how the division happened, and from here it started merging back. So if you see here, there are 7 the time complexity at this particular level is 7, because there will be 7 elements or 8 elements. Sorry, this is 8. Basically this is the value of n. So basically there will be 8 comparisons and 8 replacements. That's what I'm trying to say. And now if you see in this level, again in this level it is 8, which is equal to n. Again in this level 8 merges, so again it is equal to n. Now if you see at each level there will be n number of merges that are happening. Now if you see its height, it is 1, 2 and 3. So height is 3. So if you see, it is of log n, because log 8 to base 2 is 3. Now in each step it is n and the height is log n. So it is of order n log n. So this is one more way how we can analyze the time complexity for this particular algorithm. Okay, and what about the space complexity? So during merge, what we did, we took a third array and then we copied, or we compared elements from 2 array and we copied the element to the third array. So it means at each level, we need extra space, which is of order n. N is basically this length of the array. So at each, wherever at each stage merging happens, it takes an array of order n. That's why its space complexity is order of n plus Since it is recursive function, it takes an auxiliary stack space which is of order, it is height. Height means it is equal to log n. So order of log n. So order of n plus order of log n. But since order of n is bigger, so somewhere it is close to order of n. So the space complexity for this merge sort is of order n. So this is it about the merge sort. Let us look into the code for this particular merge sort. Let's continue in the same merge sort.js file that we have created in our previous video. So before this merge method, I will try to create a method which is merge sort. It accepts a low value and high value. Now if low is less than high, then what I will do, I will divide my array. So for that, what I need a constant mid value, which is a floor value. That's why I use math.floor, and then I will sum up high and low value and divide it by 2. So this will give me the mid value. So from here again I will try to call my merge sort method. So it will take a, will take low, and the high value will be mid now, since we are dividing it at the mid value. So again I will call my merge sort the same array a, and now my low value will become mid plus 1, and then my high will be high. After this, what I will do, I will merge the values. So for that I will have to pass a, so I will have to pass the low value, then mid value, and then high value. So this should sort the values for me. So what I will do, let me try to make modification. So let's try to use the same example what we used: 21, 15, 7, 8, 3, 5, 12, and 14. Instead of merge, let me call merge sort. It accepts a, low is my 0, and then it needs the high value, so I'll pass a dot length minus 1. Now, so this should sort and place back my sorted values into the same array. So if I try to log the array A, I should be able to get the proper sorted values. So let's try to open the terminal. I will switch to sorting folder. Now I will try to run the merge sort. So for that I will use the node command. If I hit enter, so if you see here, we will get proper sorted array: 3, 5, 7, 8, 12, 14, 15, and 21. This is what we saw in our dry run. That's it for this merge sort. We will look into its advantages in the next video. Thanks for watching this video.